Welcome back. It feels like it's been forever. First things first, let's throw the math on the top of your paper as we get the math on the top. That's putting your name on the top of your math paper as we get ready to do more math. Now, for today, guess what? We're going to be doing more things with equations and formulas. Pretend not to be tired of this already, because this is learning how to speak algebra. Now, what's important about this lesson is we need to learn how to rewrite equations. And it follows the same general rules, except you're going to see we're working with a lot less numbers today than we have been in the past. Our central question, if you guys would underline this, is how can you use formula for one measurement to write a formula for a different measurement? Now, what this means is we're going to be using one formula but rewriting it, writing it and solving for a different variable. So it'll be essentially the same formula but serving a different purpose. Sort of like when we have the density equation that we've worked with, density equals mass times volume, but we know that we can divide both sides by V, so we get density divided by volume equals mass. I'm going to apologize right away and say I don't have my regular pen, so I will try to write a little bit neater. Sorry about that. So each of these problems has very specific directions. First, we need to work with a partner. That's me. But we need to write a formula for the perimeter P, and then we need to rewrite this by solving for W, and I'll show you where that comes from. And lastly, we need to use that new formula. But we have to follow in those three steps. Let's use this space here, and let's do step 1. Write the formula for the perimeter of a rectangle. For any rectangle, we know that P is going to equal 2 lengths, or 2 times L, plus 2 widths. We did this earlier, so I hope it's not too foreign. Now, what we need to do is solve this formula for W. If you guys want to use your formula as a reference, that's okay by me. And let's look, what is the farthest thing away from W? We want to get W all by itself. So let's move 2L. The opposite of, you always see how it's related to W. 2L is being added to 2W, so we're going to subtract it away. It's a positive 2W, so we'll subtract 2W from both sides, 2L from both sides. So we get simplified. So we get P minus 2L equals 2W. Now, algebra does some cool things here where we can actually leave things in a nice simplified state, because watch this. If we have to get 2 or W by itself, we divide both sides by 2. Let's draw a fat line under here, divided by 2. That simplifies out, and we end up with P minus 2L over 2 equals W. So way to read this is the perimeter minus 2 times the length, and then all of that is going to be divided by 2, and that will give us the width. Let's put this into practice. So we can rewrite our formula, but you can rewrite it just like this if you'd like, or you can just put in parentheses. That'll be a little bit easier. I'm going to do this just because I deserve to take the long route, and that's okay. Now, if you guys see here on our original rectangle, we know what the length is, we know what the perimeter is, but we don't know what the width is. So let's plug in all the things that we do know. So perimeter, let's do parentheses minus 2 times parentheses all over 2. So we have 2 things to substitute in. Perimeter equals 19. And length is 5.5. So now it's as easy as just doing some simple math. 19 is just 19 minus 2 times 5.5. It's like saying 2 times 5 is 10, and then 2 halves is 1, is 11. All over 2. 19 minus 11. Just simplified. I'm going to write that over here. 6 over 2, and 6 divided by 2 is 3. So is it fair to say that our width is 3 inches? I think so. Now that first one I did the slowest, let's speed this process up a little bit. So let's quickly write the formula for a triangle. The area of a triangle, which would be area equals, area of really any polygon is base times height, but we know a triangle, they're going to cut that in half. Now it says let's solve for h. So 2. Let's get rid of everything. Let's get h by itself. We have 1/2. It's related to h. It's being multiplied to h. So let's divide by half, or multiply by the reciprocal, which is 2 over 1, or just 2. So we can multiply both sides by 2. So we'll get 2a on this side equals bh. And in order to get rid of b, we just divide it. It's related to h by multiplying, so do the opposite, divide. So our answer for 2 here is 2 times the area divided by the base will give us the height. Now let's put this into practice. What I'm going to do is just write parentheses down. So I know 2 parentheses, parentheses, then divided by parentheses. Area is already given to us as 10, and then the base is given to us as 5 over 2. This is going to require a little bit of fancy math. Let's do some simplifying. 2 times 10 is 20 over 5 over 2. Now, this is read as 20 divided by 5 over 2. And how do we divide by fractions? We multiply by the reciprocal. So what we can do is 20 times the reciprocal of 5 halves, which is 2/5. We can go 2 times 20 is 40, and then 40 divided by 5 is 8. Looks like our height is 8. And does that make sense? It's a lot taller than 5 over 2 inches or 2.5 inches, and that makes sense to me. Now we get into the land of pi. Don't be scared, we can do this. Just follow my lead. First we write the formula for circumference. If you already know how to do this, then you can just work ahead of me as I go. So now circumference equals pi times the diameter, but all the diameter is 2 of the radius. You see how they only gave us a radius here? So let's just keep it, so they didn't tell us diameter, so we'll use 2 of the radius, or be radii, plural. Now they want us to solve this for r, and let's just divide things away. So pi and 2 are being multiplied to r, so let's do the opposite by dividing them away. Pi over 2, both sides, divided by pi over 2. So simplified, this will just give us the circumference divided by pi times 2 equals the radius. We've rewritten it to serve another function. Now let's put this into practical use, and let's go parentheses divided by pi 2 equals r. We only have one substitution to do, but some fancy math. So our circumference is 8 pi. Now if we look here, pi, we can rewrite this a little bit so it looks nicer, which would be 8 pi over 2 pi. Pi divided by pi any day of the week is just going to be 1, so that disappears. 8 divided by 2 is just going to be 4. So our radius equals 4 centimeters. Does that make sense? I would say that does. Now, the book has a way of saving the best for last. These ones are probably the most difficult, but will follow the same rules. So let me give you the formula. For the area of a trapezoid, means that the top and bottom are parallel to each other, but the sides aren't quite. In order to do this, it will essentially be base times height, except an average of the bases times the height. Remember how to get an average of the base? If we add the small base plus the big base and divide all of that by 2. And then multiply that by the height. That will give us the area. Now what's cool about this is we can multiply by big groups of things in order to move parts of an equation. So follow along and write it down just as I do. First thing let's get rid of that 2. Now here, how is 2 related to h? It's dividing h by 2. It's on the bottom. See, h is on the top. So we would multiply both sides by 2. So we're left with b plus big B times h equals the area times 2. We moved it over, did the opposite. From here, that way. Now we need to get rid of this b plus big B. You see this parentheses? How this whole thing is relating to h is it's being multiplied. So we can divide both sides by parentheses b plus b divide b plus b. Now do you see how everything in here is exactly the same? That means it can cancel out because it's exactly the same. Anything divided by anything that's exactly the same as it is just 1. So we're left with h equals 2 times the area over parentheses little b plus big B. Now it's just a matter of order of operations. Also, I always like to write my numbers first before my variables. So that's why I wrote it like that. So this is part 2. And lastly, part 3. Let's do some substitution. 2 times parentheses over parentheses, smaller parentheses, plus small parentheses, big parentheses, equals h. Now, our area they give us is 15. Our little b is 4. Our big B is 6. Let's do some order of operations. Let's work with our parentheses. And we can do the top at the same time. So that simplifies 2 times 15 is 30. And then little b plus big B is just 10. 30 divided by 10 is 3. Looks like our height is 3 inches. That's an h. And I like to leave a little one for you to do. So I'll write out the formula for you and you can finish it off yourself. We know, number 1, the area of this parallelogram is just base times height. Easy stuff. Let's solve for height. All we would do is divide both sides by b, or you get area divided by b equals h. Do you see how b just went down there? And you can fill in the rest of the details. Alright, we got a couple more. These ones only get a little bit more complicated. There's only going to be a few more substitutions, but the principle remains the same. So we write this down just like every other one. The volume of a prism is the area of the base, or big B, like they gave it. It's already in inches squared, if you see that, times the height. Solve it for h. We'll just divide both sides by b. See how that moved right down? We're starting to see a pattern of how these things move. And then lastly, let's substitute what we know. Parentheses, parentheses, divided by parentheses, parentheses. The volume is given to us as 60, divided by 12. If you remember from last year's math minutes, that just equals 5 inches. For these two, they ask us to solve, we'll first write the area for volume and then solve for this big B. Now last time we had a big B that was just different from little b because there's two of them. This big B, remember again, is the area of the base. And then we'll use that new formula. Now if we see, this sort of looks like a cone-shaped thing, and we've actually dealt with these little in review questions. But the formula for this will be volume equals 1/3 the area of the base, which is this big B, times the height. Let's do some fancy pants rewriting. Now, the opposite, or the inverse operation of multiplying something by 1/3 is dividing by 1/3. And in order to divide by a fraction, you multiply by its reciprocal, or 3 in this case. So we have 3v equals area of base times height. We need to do one more thing, we're not quite done, is divide both sides by b. So our final formula is 3 times the volume divided by the area of the base equals the height. Now let's use this info. Let's do our parentheses. 3 times parentheses divided by parentheses equals big B, or the area of the base. You can fill in the rest. Here we'll just have some funny workings with pi thrown in the mix, but that's still write down our formula. So volume equals the area of the base times the height. Let's solve for area of the base. Divide both sides by h. So we get our formula, functional formula, will be volume divided by height equals the area of the base. Let's substitute in our known information. Parentheses, parentheses over parentheses. Our volume, as you can see, is 48 pi. Need a little bit more space. Divided by 12. Now what we can do is just do 48 divided by 12 and treat pi sort of like a variable. It just sort of chills there. If you remember from your math, that's 4, and pi is still there. We haven't touched it. 4 pi equals the area of the base. 4 pi cm squared. And our final formula for the night is this funky cone. Welcome to the final formula of the night. If you see there, we've already referenced, or we've already done the formula for a cone-shaped thing. We can use that same one. So we can do 1 is v equals 1/3 base times height. Oh, wait a second. Oh, this time they want us to solve for h as opposed to b, or height. That's okay, we can do that. Same thing like we did before. We multiplied both sides by 3, because 3 times 1/3 is just 1. So we get 1/3 b times h. I'm blowing up on Facebook. Sorry. So we get 3 times v equals b times h. Now last time we divided both sides by, I made a mistake. I accidentally solved for h instead of b. Now if you guys see here, did it make a difference? Actually not, because these guys easily go back and forth. I can divide both sides by b or divide both sides by h, and the formula is going to look virtually the same. It really just depends where you do your substitution. Ha! I hope you caught that mistake, actually. I'll be paying for it later. So let's divide both sides by b, like we did last time, but we'll do it like we're supposed to. 3v divided by b equals h, solving for the height. All right, let's use this information and plug it in. So 3 times parentheses, my space, more space, all over parentheses. Fill in our data. It's 18 pi, and base is 9 pi. Now check this out. This happened once before, where pi divided by pi cancels out. And then tell me, we can do 3 times 18 and then divided by 9, or let's just do 18 divided by 9, which is 2, and 2 times 3 is 6. Look at that. 6 is our height. The last thing is, please spend a moment or two saying just a statement or two of how you can use a formula for one measurement to write a formula for a different measurement. Meaning, if we get base times height to get the area, how can you use that formula to get the base or to get the height? And rewrite things like that. Or you can perhaps use it with our science formulas that we're doing, with density, or with different proportionality constants that we've been using, and give a quick example. So that's a few. If you'd finish out writing that on paper, and I will see you in class.